derivative f prime is going to be take that exponent down and multiply it with the constant coefficient.
We
X stays the same.
on Tuesday. So I already
And you're going to
saw this one.
subtract 1
We're gonna
from
see
your
it again.
exponent.
Oh, okay.
Because I make it up.
That's it. It's multiplication and subtraction. That's not so scary, is it?
Oh, that's.
Is it? Sorry, I'm in a mood today, guys. I went camping this weekend, and I was so dirty when I got home on Monday, that I drew water to soak my feet so I could actually like clean them, and I stepped in the tub that was already full of water, and it left a mark where I put my foot down. It's like, that's pretty filthy. We had fun. Camping is fun.
Where'd you camp?
Somewhere east or west of Winter Park this time. Always dispersed. I don't do campgrounds. They irritate me. I don't like paying to be right next to the toilet that stinks and right next to my neighbors that sing all night long. Like, that's not any fun for me. I want to be out in the middle of nowhere with no one near me. I'm a cranky old bitch. That's basically. So let's look at this. There's a little hidden something going on right now. Oh. So let's use our knowledge of the shortcut and tell me what the derivative is going to be, guys. What's 5 times 3?
15.
5 minus 1 is
4.
4. You guys really shouldn't be that afraid. 3 times 12 is? Yeah. And 3 minus 1 is? Okay. 1 times 10 is? And 1 minus 1 is? Oh. So we're going to have an x to the 0th power, which is
It's
what,
just
guys?
10. 1.
1, right? So when you get x to the 0, it's just a 1, right?
Do you have to write it down?
No. But if it helps you to put it there to show where everything is, totally fine. But you're not going to need it. You're going to be racing through these in like 10 minutes flat because they're really not that hard. The tricky part, and there's always a tricky part, is making it look like this. So when I tell you guys something like, make it pretty, and I do, I call it making it pretty, I mean make it look like this. So that you can take the derivative. So if you have a term that doesn't look like that, some form of that, make it look like that so that you can easily perform the derivative. Ruby,
Wait, quick question, how did you get the 4?
you tell me.
I don't know, I'm asking.
Pattern, what's n minus 1? That's just the exponent minus 1. So if our exponent was 5, what's 5 minus 1?
Oh,
Exactly. Awesome. Yes?
I'm trying to understand that red part.
That red part, this is x to the 0, which is the same as 1. Anything to the 0th power, I don't care if it's 10,000. If it's to the 0th power, that equals 1.
So the x goes away.
Yeah, the x is going to disappear. Look at what's happening here, guys. We're losing an x on each term every time we take a derivative.
Yeah.
That's essentially what's happening.
How
So
come
if you
the
have
x-
10x, this is going to become 10. What?
How come the x would disappear though?
Because of the nature of the derivative.
So the second one is the derivative.
Second
of the
one is
top
the derivative of the top one. Yeah. Oh, crap. Missing a slightly important thing there. That should read y prime. Y with a little apostrophe.
So the y prime would be the final answer?
Y prime is the derivative. Yeah.
Cool.
Yeah, that's it.
Easy peasy.
See, that wasn't so bad. Yeah.
How did you get 15?
Come on, DeMarco.
15. Ah, the 15 came from the 3 times the 5. So the step here is you bring your exponent down and multiply. That's what this is. Okay? And then your x drops and you subtract 1 from your exponent. So multiply your constant coefficient and your exponent. And then subtract 1 from the exponent. That's simple. Let's do another. Sometimes I feel like Wolverine. I like coloring cultures. Oh,
I'm a horror movie buff.
I want to be a hero.
Wolverine.
I suppose, like this is excellent. What? I had to watch I lost track of the Marvel universe. I was like, okay, I'm over it. I was pretty much over it with like Iron Man 2.
Yeah.
It's just too much. How about this one? What do you guys think?
Negative 12x to the negative 10.
Good. What happened to that negative 10?
It goes to 1.
Oh, say that again.
Disappears.
Why does it disappear?
Sound nice.
Because it doesn't have an X. So think of it as an oh no, don't think of it as an unaccompanied minor. We killed it. No, think of it as it didn't have its X protection. It doesn't have an X down with it, it's gonna die, okay? When you walk through and you slash and burn and you steal X's, there's no X to steal, so you just take the constant. Constants by themselves die. And that's another rule I need to put up here. If your function is just some constant, C, then the derivative of that will be 0. So constants die. Constant coefficients go along for the ride. Notice here, this 3 did not disappear. It became part of 15. Constant coefficients tied to x's go along for the ride. You guys with me? Okay. Constants by themselves, you killed it, killer. Groovy? You ready for another? You're not so bad. How about this one?
Yeah.
And you're like, say that one more time. Give you guys a little reminder. This is a square root, so there's a hidden 2 there and a hidden 1 there. Is it pretty?
No.
Is it an ax to the n form? Can you make it pretty? Yeah. So remember how we spent time converting these?
X, 1/2.
Good. Yes, x to the 1/2. I heard it from several people. Okay. Now it's pretty. It's in some x to the n form. Wonderful. What's the derivative? The derivative of y with respect to x equals. Yeah.
Well, that's still a bit.
Good. Plus? Bring the 1/2 down. What's 1/2 times 1? 1/2. What's 1/2 minus 1? Negative 1/2. Now, I'm going to talk you guys through some tips and tricks that I've discovered over the years.
How come you wrote it as dy over dx
Ah, did you read the handouts that I gave you?
briefly?
Pull out all the ways to say derivative. It's on there. Yeah, it's on there.
It's because of the specific type of problem, right?
No, it's just another way to say y prime.
Okay, so you could have put y prime.
Mm-hmm.
Okay.
Sure could have, but I'm going to start exposing you guys to all the different ways. So this is my little tricky way. And you fell into my trap and said, "What's that?" Which is okay because it happens every semester, so you're fine. All right, here's a trick. How many of you hate fractions? Get them up. Oh yeah, good times. How many of you hate subtracting fractions? So if I had 3/7 and I wanted to subtract 1, the old way is to find a common denominator. Oh my dear God, this is boring, right? We have a faster way. Top minus bottom. What's 3 minus 7?
4.
What kind of 4? That's your new numerator. Done.
Oh.
Top minus bottom. So anytime you're subtracting 1, it's the top minus the bottom. So what's 1 minus 2? Negative 1. That's your new numerator. You like? So let's try a couple of these. What's 4/5 minus 1? What's 7/3 minus 1? 4/3. What's negative 10 thirds minus 1?
Negative 7 over.
Negative 10 minus 3 is.
Negative 13
Oh,
It always works. I like shortcuts. I'm lazy. Be lazy with me. It's more fun than doing the hard work. How do you guys feel about that? Okay. So with that in mind, let's play with some fractions, shall we? Let's try this one. Two steps to make it pretty, and then the derivative is your slash and burn. So, step one, how do I make this pretty? Before I do, I need an exponent that I can drag up, so let's create an exponent. So this is x to the what, guys? Yeah, so this is like saying x, cube root of x is x to the 1/3. Now if I drag it up, what does my exponent become? So before I take the derivative, this is 4x minus 13 plus 5x to the negative 1/3, right? So now I'm ready to take the derivative. One baby step in the middle, and then you can take the derivative. Be excited, guys, it's a two-step problem. It's gonna be a lot worse. What's my derivative, guys? The derivative of y with respect to x is 4.
4x to the negative 1.
Yeah. So on the side, I'm not, hang on, sweetie. Okay. So negative 1/3 times 5 becomes negative 5/3, and negative 1 minus 3 is negative 4/3. You're saying where did the x go here?
Yeah,
Well, what's my exponent here?
1,
So 1 times 4 is,
4,
and 1 minus 1 is,
oh. Okay.
Which is
okay.
and then the 13 just goes away.
Right, you killed it, killer. Constants
So
by
first
themselves
you
die when you take
there's a 1
derivatives.
here, obviously. But
Yeah,
you
I
can't
know
do 4 times 1 is 4. And then when you have an x by itself, basically la quitas. Y ya nomás se queda el
Don't worry,
concept.
we resurrect them when we perform
Exactly.
integrals, they're the zombies
Here's
in
the
the math
confusing
world.
stuff.
Yeah.
It's true, we resurrect those
That's what she
constants.
did.
So relax, they're not dead forever, they're only dead for a while.
Over 3. And then that's the exponent, right?
Makes me
Negative
very
1/3.
happy.
Did you ever see Pet Cemetery?
Yeah, so
You mean the
basically,
original?
it's
Yeah.
when
The
you,
one that
when,
kept me up
when
screaming
you,
as a child?
want,
No, I never saw
when
it.
you want to subtract,
It's
subtract,
because I don't like seeing it.
you're subtracting,
Kind of thing. I might watch it
wait, what are you
now,
subtracting?
because I'm not really afraid of horror movies, but when I was a child, that would have been scarring, don't you think?
I had it for like a
Okay,
second.
it was actually much worse.
Le
it
digo que le
worse?
explico otra vez.
Oh, and that's when, oh my gosh.
Well, that sounds awful. So is everyone cool with this minus 5/3 here? And where it came from?
No.
Yeah, talk to me.
Can you explain how you did the red stuff?
This stuff here? Okay, so all I did was I dropped my negative 1/3 down. The 5 and the negative 1/3 are gonna get multiplied, giving me negative 5/3.
Okay.
And then I subtracted 1 from negative 1/3. So what's negative 1 minus 3?
2, negative 1 minus 3.
Yeah.
4, negative 4.
Good. There it is. There's your new numerator.
Oh, okay, makes
See it?
sense. Cool.
Awesome.
That makes sense.
You want another?
Yeah.
Okay,
Ay,
so
sí
este
lo
sí lo
entendí.
multiplicas. Este sí lo
Yeah,
multiplicas.
you multiply this, and then I guess this,
You
you
just minus
subtract,
one.
and then that's what gives us
Mhm.
that. Cool. ¿Sí lo entendiste?
I don't know why I'm
Sí,
so
sí, sí.
excited about 1/10.
Bueno,
I need to make
yeah,
that
that's
into
the thing.
something else.
Yeah, me too.
That's why I do it over and over and over. Esto es lo medio raro, pero a veces when you
That's fine.
by one,
Whatever.
nada más you subtract the
Lots of
numerator
stuff going on there.
minus the denominator.
Is it pretty?
Over the denominator.
Is everything
So
an
that's
AX to
why
the
it's 1
uniform?
minus 3
No,
is
can we
negative
make it
4
pretty?
over 3.
Yeah.
Yes.
Okay.
Siempre que ves así minus
So what do
1
I
is
do to
just
this one?
numerator minus denominator over the
Okay. Cool.
5x.
To the 1/2,
And so when I drag it uptown, what travels with the 1/2?
negative, oh, the x.
Yeah, it goes negative, but just the x,
Yeah.
right? Not the 5. The
No.
5 is not attached to the 1/2. So I'm gonna rewrite this as 1/5 x to the negative 1/2 minus 100x cubed plus 5x. Now we're ready to take the derivative, right guys? That's not so bad. Okay, so what's my derivative? And -1 minus 2 is? -3. What's this one gonna be? -100x cubed. Yeah, minus 300x squared. And what does 5x become? 5. Okay. So what's -1/2 times 1/5? You guys remember fraction multiplication, right?
Negative 1/10.
Straight across, good. So this becomes -1/10 x to the -3/2 minus 300x squared plus 5. Yeah.
Okay, so that's 5x cubed, or x, square root of x, 5 is square root of x, up there,
Yeah.
at the very top.
Yep.
So does that 5 have a 1 exponent?
Nope. It's a constant coefficient, but my constant coefficient is actually 1/5.
And so just because you took the square root of x, it was 1/2?
Right, so when I drag this x to the 1/2 up, the 5 is gonna stay downtown. It's not attached to the exponent. So think about grabbing this exponent and yanking. The only thing that travels with it is that which is attached. The only thing that's attached is the x, so the 5 stays downtown. Okay? You guys wanna see another?
Yes.
Yeah.
Yeah, see, I'm not so bad.
Wait, so just the fact that it was the square root of
There's
x
just too many
made it an
steps.
exponent of
Yeah.
1/2?
Yeah. Yeah. The pattern is that.
I have a quick question.
I have
So
an
with the
answer.
step between the 5 square root x and the 5x that I have,
Oh, this little dot?
higher up, the black and the red,
Here?
that one.
Oh,
Yeah.
this was just my like scratch paper in between and
Okay.
converting this to a x to the 1/2.
And would there technically still be a
Oh,
1
yeah.
over this at this
Yeah.
point?
Yeah.
Okay, cool.
Yeah, so
That's
that
what I
entire
had.
term would look like this.
Okay, thank you.
Sure.
And then it goes to the one below it.
And then it goes to
Okay,
the one below
thank
it. Mhm. Okay. What else?
Is there a reason why there's so many damn ways to write that it's a derivative?
Yeah,
Yeah.
yeah. Mhm. Good ones.
Not just the thing?
Yeah, not just for fun. Math is messy, okay? So there's formal ways and informal ways. The formal way is performing the derivative of the function with respect to x. That's the formal way. Informal, y prime. Where the hell do I have a y prime up here? Nowhere. But if I were to write y prime or g prime or f prime or anything like that, that's an informal way. And then we have applications where the derivative means something specific. Like if you're taking the derivative of revenue, its derivative is marginal revenue, which is something that might sound familiar to you if you've taken a business class. So it has its own way of representing the derivative. So revenue R becomes marginal revenue MR with a line over it. Okay, that's why, because there's so many different things we can do with this. It's not a one size fits all kind of thing. make sure I have every type of example here I want to give to you guys. Okay, great. Let's do something a little bit different now. That was easy. Marginally, right? Get it? Marginally. I'm in a mood. F of x equals 3x squared plus 6x minus 10. Find the slope of the tangent when x equals 2. What am I asking you to do? Put 2 into what? When you plug an x into a function, what do you get out?
That was mine. Good.
A y, but I'm looking for slope. So I'm not gonna plug it into the original function, I'm gonna plug it into the derivative. So this is why I've been sort of hammering that roadmap for so long, because we build on this roadmap. If you plug an x into the function, you get out a y. So if you want y values, you go to the original function. Plug an x into a derivative, you get out a slope. So if you want a slope, you go to the derivative. So it all depends on what you're asked to find. You guys cool with that?
Yeah.
Okay, so I said find the slope of the tangent. The tangent line is that I rock, right? That thing we talked about last time, the instantaneous rate of change. So find the slope of the tangent when x equals 2. So what am I asking you to do basically? Right? And then we do what? Yeah, we shove 2 into it. So this is what I'm asking you to do, f prime of 2. Take the derivative, plug an x value in, and see what barfs out. Not that bad. What's my derivative? What?
Find the derivative first, then plug 2 into the derivative. And whatever you get out is the slope.
Yep. So what is f prime, guys? 6x plus 6. Now plug a 2 in and see what happens. Yeah. 18. And that's that. Not so bad. It's not quite just 18, is it? Because slopes are rise over run, aren't they? Rise over run. So this 18 is actually 18 divided by 1. Yeah.
We have to write that out.
No. Unless it says interpret the answer, like in an application problem, you're gonna wanna interpret this. This would be the correct interpretation for this problem.
Well, it is a mark, but I don't.
But if I tell you to interpret it and you don't, yeah? Fair enough, right?
Yeah.
This is why RTFQ is my favorite thing, guys. What does that mean? Here's the clean version. Read the full question. Read it fully, read it thoroughly, read it completely, read it twice, right? Read the full question.
What's
So
the
if I,
non-clean version?
you imagine it,
I don't have a great
as everyone secretly clicks record. Yeah,
I was gonna say Mona likes to use that too.
yeah, I imagine. Does she say read the full question?
Yes.
She doesn't make it dirty? Yeah, 'cause we're all adults here. Read the full question, guys. Just read the flippin' question. All right, so your interpretation of this would be as x goes from 2 to 3, we expect y to rise by about 18. Anyone want to take a guess as to where that 3 just sort of came up out of nowhere? Anyone?
The original.
The next one. So if we start at 2, we run by 1. Where are we going?
3.
To 3. So we're running from 2 to 3. We're going to rise by approximately 18. Remember, you guys, if your original function looks like this, and your x value is here, right here, this is the instantaneous rate of change or the slope you're gonna find, right? If you just go over by 1, this mirrors the behavior of the function, at least initially. But the further away you get, the bigger the error becomes. So we only do this for near future, always by 1, always, 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 always. Ryan?
So the reason why we write expect and about 18 is because these are all
Estimations.
estimations. Cool.
Absolutely. Yes,
That little squiggly line in front of 18,
Means about.
means about.
okay.
Okay. All right. Yeah.
You can say, but if you do it as like F prime 3, it's only 24.
Because you're going from 3 to 4. Aren't you? At that point. If you're doing f prime of 3, you're analyzing the thing at 3. So you're saying, what happens if we go to 4? You with me? Okay. Is everyone cool so far? Kind of, at least? Give me a thumbs up if you're good. Thumbs are good. Give me a shaky if you're just a little, okay, I see a couple of shaky thumbs. All right, give me a thumbs down if you're just like, I have no flipping clue what's happening here. I'm just lost. Come visit me. Okay. You can get yourself away by laughing, so I'm sorry. All right. Come visit me. I swear I don't bite much.
There you go.
There we go. Okay. Let's do a different one. Find the equation. Find the equation of the tangent line. To this function. Okay. At x equals 1. So first of all, what the hell did I just ask you to find?
The equation
Of a what?
of a tangent line.
Equation of a line. And what is the equation of a line?
What?
Good. Let's think about this for a second. We're gonna need, we have an x, so we're good, we've got an x. X is 1. We need a y, an m, and a b. So where do we go to get m? What's slope? M is slope.
Rise over run.
Rise over run, otherwise known as?
F prime.
Where do we go to get slope? Yes, we go to the derivative. So we're gonna plug 1 into the derivative here, okay? So what is the derivative?
Let's find out.
Yes, let's. Plus 2. Now, plug your 1 in and get your slope out. Yeah. That is my m, 14. Now I need a y and a b. Where do I go to get y's?
The original function?
Yes! And this is why this roadmap is super easy. If I need a y, I plug x into the original function. That's what these roadmaps are here for, to remind you of that. So I get y from f of 1. So let's do that. What is f of 1? 4 times 1 cubed plus 2 times 1 minus 14. Yeah, negative 8, thank you. Sorry, I was still working on it.
And this is to get, what are you getting, the X or? the-
I was getting the y.
Oh, the Y.
Yeah. So now I have everything except b. Can I solve for b?
Heck yeah, we can.
Heck yeah, we can solve for b. So negative 8 equals 14 times 1 plus b. Negative 8 equals 14 plus b. 22 equals b. Is everyone cool with that? Okay. Now you guys see why I work in multiple colors. I color coordinate everything. Everything.
It'd be negative 22.
Oh, yay!
Yeah.
Extra credit.
Adam,
Ryan.
and Haley. Is it A-L-E-Y or A-I-L? I-A-L-E-Y. A-L-E-Y, okay. Ryan. And Haley. Okay, extra credit for you guys. Hot damn. That's what I'm talking about. So now, what is that actual equation? Mm-hmm. Y equals minus 22. You guys see that? And you're like, why do I care? This is that instantaneous rate of change line that I was telling you about before. The slope gives us an idea of what slope it is from that point. But the definition of a line, in order to graph it, needs x's and y's. Grab your calculators. Yeah. We're gonna graph this puppy. Actually, we're gonna graph this puppy and, where the hell is it? This puppy, right here. So the two things I'm boxing, I want you guys to graph those together, all at once. Pretty please. And I will too. Here.
Oh,
When I graph these together, so everyone's gonna have a different window to start with in the calculators. So the first thing I see, so I'm just gonna show you guys what I have. And you guys are gonna tell me what I should do. So whatever window I have, this is what I get. I get this. Does anybody wanna tell me what I should do to see the whole picture?
Zoom out.
Zoom out? Where though? I have what I need here, so do I need more X max?
Wait, are we plugging in the y equals 14x minus 22, or are we plugging in the?
Both.
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 Oh.
Yeah. We want to see them both. So,
Does it matter which one first?
no, not at all. One's the original, one's the definition of the equation, well, we'll get to that.
You just need to like zoom in.
One's the
right?
original function, that's this curve right here, and one's the line, that's this right here.
That's
So
what she's
I don't
talking
need any more X max, but what do I need more of? Do I need more Y max?
min.
Yeah, I need more min over here, so I'm gonna drop my Y min from whatever it was. My Y min was at negative 10. So I'm gonna take it to like negative 30, just for giggles, and let's see what shows up. Oh wow, that's much prettier. So here's my new picture. And guess what, guys? Where they kiss is at that X value that we were analyzing. You can look
Este una.
at it
One of
by
the equations?
doing calculate
You want to do one of
intersection.
No, los dos.
Which two equations do you use, the fx?
The ones I boxed.
Okay.
Sorry, how do you change the screen again?
Go to window
Let me see, -10.
and change what you wanted to change. So I changed my Y min, so it depends on your calculator and what you've got going on it.
Oh, there you go.
Oh,
Is anyone stuck with their calculator?
Mhm.
Anyone struggling? Yeah. And Memo, you're good, or was that a switch?
yeah, I was just.
Wait, like,
Invalid dimensions.
La clase se me pasa bien rápido.
You remember how the other one was like what, like 2 hours or something? Right? It was
Yeah.
longer. It was longer.
Now try it.
They should have been like that because she explains it much better. La otra was like, yeah, I just want to leave. I don't get anything.
You probably got too much.
Forgot about that. Yeah, it was like an hour and 45
Yeah,
minutes.
we had a break. We had like a 10-minute break or something.
I was falling asleep by then.
Yeah,
Let's not remember those things.
not such good times.
I know. I had that class and then I had another class which was also boring and we didn't do anything in class. So it was like, those days were the worst.
And then we had like a few snow days during that semester too. So that just made things even worse.
Yeah. We didn't go
Se
through
brincaba
stuff.
cosas la
Yeah.
señora.
And she would still test us on it.
And I remember hasta a veces se le olvidaban cosas. She was like, oh, I'm gonna redo these notes because I didn't like the way they.
Yeah.
I was like, man, this lady. The only thing that was
I didn't
nice
show
about
up a
her.
lot.
Yeah, you didn't. Huh?
Yeah, that's why. I was like, well,
That's
whatever.
even worse. Yeah, but I think the only thing that was good about her is that she let you kind of like turn in homework late if you want. But,
Yeah,
oh yeah,
she
you can
didn't
still
care.
turn it in.
Yeah. She gave you guys the points and stuff. Well, me too, because I would turn it in late of whenever no iba a clase. So I was like, whatever. Oh, that shit's funny.
That whole calculator thing, I'm still kind of like understanding, like the whole like window thing.
Okay.
Todavía no.
So I guess X max
¿Cómo tú le
is the
entiendes?
right, and then X min is the left, and then Y max and Y min.
So entonces cuando dices como, okay, so I want it to move like this, then you're gonna increase X max,
Yes.
and then if you want to go lower, you're gonna decrease Y min or whatever. Así algo así.
Yeah. It's it's confusing. Yeah. That's what I did.
It's like
in
zooming in,
class.
zooming out.
Yeah.
Okay.
Because I have -10 as X min, X max 10.
But
And
you
then
just kind of have to
Y min
play with it, así
30.
como
Yeah.
common sense, ¿no? Porque,
Yeah, well, I took stats, and that's what taught me how to do this.
okay, I've
Yeah,
never taken that.
but it's still confusing. That was like freaking 4 years ago. Dang.
Yeah.
Yeah, that was a long time ago. I still remember some things, but
Yo casi no había tomado así clases de matemáticas muy like I never taken calculus or anything like that. So I was just like, I don't know anything. I was so afraid of taking
they're
any
just
of
dropping the ball on you. Yeah, they told me they were like, do calculus in high school, and I was like, no, do stats, because stats is easier. And then, yeah, well, stats.
What is your major?
CIS.
Okay.
Oh, okay.
Yeah.
So this is a requirement, no?
Why, my major was accounting and then I switched.
Oh,
Yeah, because accounting not working.
yeah.
We cannot be best friends.
Everything would
I
change.
swear.
Okay, so you guys notice what this function looks like, right? Your function was a cubic. If I change the value that we're analyzing from 1 to 3 out here, my slope is gonna change, my whole thing is gonna change. The definition of the line, everything is gonna change, including my corresponding y value. So I would have to do this all again with a different number. Does that make sense? So that's why this is so powerful. It's unique and specific to a specific location on the function, namely that one x value. Change the x value, everything changes.
So the function's a squiggly line and the straight line
Is the tangent line. Yep. Questions so far? Really?
You actually said something about running the intersect function on.
Yeah, you can do the intersect to check your work, but as he found, it kept diverging to this intersect down here, because eventually this is gonna drop down and this is gonna
Yeah, that's.
intersect it again,
mine was
so
like
it's still doing that.
-2, -50.
So if that's the case, then you can do value and make sure to test it on both functions. So you can do value and make sure the function in the upper left-hand corner is the first one, and then change it to the other function and do value for the same thing. You can test one and you should get the same x value and the same y value. Groovy? Okay. This is powerful in another direction. It's not just about finding the equation of the tangent line. We can find places where certain slopes exist. For example, what if I ask you to do this? Not with that color. This color. Find the x values where the slope is 0. And here's your function. So what am I asking you to do here? I'm asking you to do something with slope, so we're gonna need be what? Derivative, right? But instead of giving you an x value and asking you to find the slope, I'm giving you a slope and asking you to find the x value. So how do you think you're gonna do that?
So you're asking us to replace y with 0?
Not y,
No?
M.
not m, well, yes, m, but y prime.
Y prime with
We're
0.
gonna be replacing y
Okay.
prime with 0.
After we've gotten the derivative, okay.
Exactly, so my first step is take the derivative, right? So slope is 0, that's like saying f prime equals 0. So in order to do that, first I take my derivative, which is what, guys? How many of you are getting easier and easier with the basic derivative process? It just starts to roll off your tongue after a while, and you do it without even thinking about it. You guys are doing calculus in your head.
Freak it out.
Yeah. No, just go ahead and say it.
We're good.
Say what you mean. Don't hold back.
Read
You're not the one
fucking
up here.
questions.
Say what you
I found
mean.
it out.
Seriously, guys, you're doing calculus in your head. Calculus is not as scary as people make it out to be. It's really not. What do I do now?
So f of prime of x also means y prime?
Mm-hmm.
Yeah. Did you plug in x? Or, 0, sorry, 4x.
So
Yeah.
I'm gonna literally set this equal to 0. Now what? Put the 2 over. So -2 equals 8x. -2 over 8 equals x. X is essentially -0.25 or -1/4 or, whatever floats your boat. Do I care if you leave it like -2/8? No. Do I care if you make it -1/4? No. Do I care if you make it -0.25? No. They're all the same. Mathematically, they're correct. I'm not gonna waste my time doing simplify, and I'm not gonna waste your time making you simplify fractions. That's some BS. That's for like algebra. This is calculus. We're moving on, okay? How do you guys feel about this? Now graph your function.
I was gonna say, could we just graph that and find the minimum and maximum?
Yeah, but this is how we find minimum and maximum in calculus. Take the derivative, set it equals 0, solve for x. And that's exactly what we just did. Nice try. What's your name? Kristen. Nice. Haley. I have an answer. What's that? What? Oh. Yeah, probably. I'm so sorry. Is that? That's your. Yeah. Is that an apple? Yeah, that's the right one. I don't know why it's not working. Do you want to use mine for now? So you can just practice? Yeah.
What did you grab?
You tell me, what do you guys
I'm
think?
trying to figure out, like,
Cool.
and for one of the equations, I put in 4x squared and all that stuff, right? Pero la otra, ¿qué?
And then
Is there
if
another?
your x ends up on -0.25, like if the line goes through your x at that point, then you were right.
You're kind of close, actually. Caitlin, you're kind of close. Did you guys read Let's Play Together in a Not So Creepy Way?
Yeah.
No,
yeah,
but
we
I
do.
really wanted
Because
to.
Now
last
I'm
time
going to.
we did this one.
Remember,
This one.
Okay.
So we.
in Let's
we
Play
have to
Together
do
in a
this
Not So
one.
Creepy Way, we had a function and its derivative, and we graphed the derivative. So 4x squared plus 2x plus 10 looks something like this. Am I right? Give or take? Does it drop below the x-axis? I don't know, because I don't have my calculator.
No.
No, so it sits above it like this?
Yep.
Okay, now, where is the zero? Or where is the slope zero? Tell me where.
Right there.
There. Okay, so that x value, we already found, was negative 0.25. So if we were to graph the derivative, it would look like this. And it would cross right at that point. Okay?
Pero es que el niño está más abajo.
The reason is,
Yeah,
my
so
dear
it
chickens,
like drops down there.
is when we're graphing the original function, which I should label f of x, and this is f prime. When we're graphing the original function, it's plug an x in, get a y out. Now it's slope. Plug an x in, get a slope out. And what kind of slope do we have before negative 0.25? It's a negative slope. So this descriptor, this is servant to this guy. This describes everything that's happening up here with the slope. This will be below the below the x-axis up to negative 0.25, right? And then at negative 0.25, where the slope is 0, it will cross the x-axis. That's where slope equals 0. Here's a negative slope, here's positive slope, here's 0 slope. And then after that, the slope is positive and getting more positive. So that's why the graph does what it does. You guys cool with us?
Yeah.
Okay, so it's really hard to contemplate having a positive y value but a negative slope. But that's the way it works. You're like, but this is positive. No, but the slope itself is negative, and we're graphing slope here, not y values. So negative slope, 0 slope, positive slope. Negative slope, 0 slope, positive slope. And that's what that is. Okay. Caitlin, was that what you were trying to say?
Yeah, it's
Awesome.
where the line that's gonna hit whatever x point is going through. I get what you're saying. I'm like trying to explain it, but like
Are you thinking of the tangent line?
I'm saying like when you said graph this, like why? Because to check our work.
She's just saying that if you graph both lines, they intersect at that point.
Well,
They don't
yeah,
intersect,
They
though,
don't
right?
intersect at that point. That's the thing.
Where
Though,
they both hit.
if you were to graph the tangent line to the function at x equals negative 0.25, it would look like this little green line. It's a 0 slope at that point, right? If I plug negative 0.25 into this, I get 0 out. So at negative 0.25, the slope is 0. My m is 0. There is no rise, there is no run. It's actually 0 over 1, but there is no rise if we run over by 1.
So what's that bottom graph for then?
This is the derivative.
Mm-hmm.
This is this guy right here. This is this guy. And this is this guy. Okay? So graphing 8x plus 2 on your calculator, you have to pretend, if you just graph this and not this guy, if you just graph the derivative, you have to pretend that you're graphing x versus slope, and you're gonna use this to describe what's happening here. So if I were to erase this, I could say my original function, whatever it was a negative slope up until negative 0.25x, and then it became 0, and then it was a positive slope. So this is like negative slope, 0 slope, positive slope. Negative slope, 0 slope, positive slope. So I could kind of redraw what was happening on my original function just by the behavior of my derivative. And we get into that in chapter 10. I don't expect all of it to make sense right now, guys. It's okay. It's really okay.
So by finding the x value
Mhm.
where slope is 0,
Mhm.
you can then say before that x value, like below, like, so before negative x 0.25,
Mm-hmm.
it would be a negative slope. Then
Mhm.
you're at 0, and then after that would be a positive slope.
Exactly.
It would never go negative, 0,
Mm.
negative.
Yes.
for like what we're doing.
So we're jumping ahead of the game, this is still chapter 10, but it's okay, I can show that to you.
Oh, that's okay.
Looks like that.
Okay.
Negative slope, zero slope, negative slope.
Okay.
And that's called a horizontal point of inflection.
Okay.
But we'll get to those in chapter 10.
Oh.
But yeah, they can totally look like that. This is exactly what I want you guys to do. I want you to ask me these questions. It's okay. This is inquiry-based learning. I throw something up and you ask questions. Yeah?
I think I was gonna ask if there's a way to use the calculator to find a point with zero slope.
Yeah. Yeah, you calculate maximum or minimum depending on what your kind of function is. So here we would just do the minimum. Yeah, but I'm not gonna let you do that. I mean, you can check your work with
That's
it
what
if you want.
check it.
Yeah, you can check your work with it if you want. But really, we use calculus to do it. But yeah, totally use your calculator to check it. It's a good tool. Yeah.
I'm assuming then you don't want us to use the derivative function on the calculator?
Oh, funny you should mention it. It's in your handout.
Yo ya tengo hambre. No he comido todo el día, so I'm hungry.
Voy a comer un sándwich que me dio mi mamá.
Oh, no, you're fine.
I wish my mom would give me a sandwich.
Are there ever gonna be problems where you kind of work backwards?
Yep, absolutely.
Can you do a problem like that?
Yeah, I sure can.
Oh, ya no puedo.
Oh yeah, I forgot. Do I have an extra one? It's like
Quiero más.
That's right, 'cause I already gave it to you. Sorry. So if you guys flip to page 3, we teach you how to do the derivative in your calculator. So everyone get your calculator out. It's not going away anytime soon. I want you to start with math. So hit your math button. I don't have mine in front of me, so I'm just gonna talk you guys through this. Hit your math, no, it's cool, you can
Math.
practice.
Yes.
I can do this from my heart, my head, it's fine. So you're gonna hit math. Now, go down to end deriv, so just arrow down until you hit end deriv with an open parentheses on it, and hit enter. Some of you are gonna get the thing on page 3. Some of you are gonna get the thing on page 4. So if yours doesn't look like the thing on page 3, flip over to the back. So raise your hand if you got the thing on page 3. The open parentheses and just a blank, right? Raise your hand if you got the thing on page 4. You page 4 people are lucky, because that's kind of how we fill things in automatically. The people on page 3, here's what I'm gonna ask you to write. So you type in everything in gray, including that final parentheses. So you were asked to do end deriv of, we're gonna do 4x cubed minus 5x plus 10. Still addicted to those 10s, it's weird. 4x cubed plus, or minus 5x. Minus 5x plus 10. And then you're gonna hit a comma, which is above your 1. Okay? And then you're gonna type x. In the same manner you got your x's for this, and hit another comma. And then we're gonna do 2, and close parentheses.
Wait, where's the
So what we typed here in black is
The what?
perform the
The comma?
numerical derivative of
The comma?
this function with respect to x when x equals 2. So you just wrote a program,
Akira.
okay?
Oh, she's above
Perform
the
the
1.
numerical derivative
Okay.
of that
Yeah,
function with respect to x
but she-
when x
yeah, you're
equals
right.
2. Yes.
What are we getting out of that? Are we getting the f of, like, are we getting the derivative, or are we getting the x value raised to 0, or?
You're plugging in x value into a derivative, which gives you a
Slope.
slope. You're getting a slope out of this. So raise your hand if you got 43 and change. Raise your hand if you got exactly 43. Okay, nobody. Now, those of you on page 4, it's the same kind of thing. This means perform the derivative with respect to x of that function when x equals 2. So everything that you have to type in is in gray, and just use your cursor to arrow from box to box. Okay? Yeah.
What
Not
if
too
you
bad.
didn't get 43?
Well, then you type something wrong.
What if I got 12x squared plus 11?
No. Are you full of it, Brian?
No. It's an 89, I know you
What
said.
did I say about
know you
89?
said, but I have already purchased.
Oh, Jesus.
Yeah.
Fine. Can you return it? These are the
No.
worst, these are the worst.
I got it, yeah.
These are,
Last-
why? Did you, why? I told you not to, why?
No, last year,
Oh,
yeah.
if you said yesterday, I'm like, I don't even know what you're doing here. Numerical derivative, 4x cubed minus 5x plus 10 with respect to x when x equals 2.
I typed it in. I'm so sorry.
Yeah, I don't have help for you. I
Okay.
told you I wouldn't be able to help you.
No,
with
that's
89.
completely fine.
I don't know what to tell you, buddy.
So well,
That is the worst calculator ever invented.
so I can actually,
It's awful.
so do you want me to, here, hold on, let me just put.
What did I say? Oh, dear God. All right, so raise your hand if you have the thing on page 4 and you got the right answer, 43 and change. So, Gesundheit, did anyone just get 43? Nobody. Good. Okay, where did the change come from? Anybody? Anybody? Math. The special math. It came from the calculator. But why? What is the derivative of 4x cubed minus 5x plus 10? 12x squared minus 5, right? Now plug 2 into that. That's 12 times 2 squared minus 5. What's 48 minus 5? 43 is the real exact answer. So why the hell did your calculator give you an error? Why did it give you 43.0000000 something? Yes? Yes. The derivative is an approximation. Let's take that a step further. What's the fundamental definition of a derivative, guys? F of x plus h minus f of x divided by h. We do the limit as x, or sorry, as h approaches 0. H approaches 0. Calculator is a dumb box. It's doing this process, but it's plugging h as 0 into this right away, which gives you a denominator of 0, which makes the whole thing blow up. So to compensate, instead of h going to 0, the calculator's like, we'll just make it really close. I'll just do that. That's what the calculator's doing. It's making it a really small h number close to 0 so that it doesn't divide by 0. That's where your error is coming in. So I will know if you did it in your calculator or if you did it by hand. Because your calculator has a little error built in. But by
Yeah, but now
hand,
you
it's
told us
exact.
about it.
Yeah, but I will still know because I'll see the work. Yeah. Yes.
So which way do you want us to go?
By hand. And then you can check yourself after
And that one
wrecking
will give us
yourself.
the slope.
Yeah, that gives us the slope because we're plugging an x into a derivative. Okay? Isn't that kind of cool? So now you can do these in your calculator, but you're smarter than the calculator because you'll get an exact answer and the calculator won't. You had your hand up?
I'm just gonna ask, like, there's gonna be, like, on the test, like, you'll ask, like, to do it every way, probably, right?
No, I mean, if I ask you to find a maximum, I'm expecting you to use calculus to do it. But pretty much anything else, like by hook or by crook. Because the point is, you're able to
Cause like now
manipulate
we
the
have
numbers.
3 methods to do this, basically, right?
Yeah,
Calculator.
calculator by hand and the formal definition. Take the shortcut, make it easier. But if I want to see all your work, you definitely can't use the calculator. You can use it to check your answer, but you can't use it to show your answer. Yeah.
Real quick,
And then,
can
yeah.
you do one of those problems backwards?
I can't, oh, the backwards problem, I kind of did though. So we did that kind of here, where we took a derivative and solved for x instead of solving for the slope. When we go backwards, a real backwards problem is integrals. And that doesn't happen until chapter 12.
Oh,
So can you hang tight for those?
yeah.
Awesome. You're like, yes, let's take our time and make it special. Yeah,
So actually, I was talking about on the calculate tab
yeah,
with the graph, it's number 6, it's dy of
Yeah.
dx.
yeah,
It's like the same thing, just plotted already.
or it should, yeah. Okay, so right now, you guys should be in good shape, yeah? You feel okay about the shortcut, at least? And understanding there's multiple ways to ask for the derivative, so don't freak out if your homework asks for more than one way. It's asking for the same thing. Your homework's gonna ask you to do it more than one way. I mean,
All those terms, like, put out for the derivative or put out for,
the slope of the tangent, that's take the derivative, plug an x in.
okay.
The instantaneous rate of change, that's the derivative. The instantaneous rate of change at an x value, that's the slope of the tangent. It's all there. It's all, yeah. There's like 12 of them. I'm not gonna go over them. Yeah, it's okay. You guys ready for your homework?
Yeah.
Yes! Oh, groovy. Awesome. 9.4. Here it is. Please do 1 through 34 every other odd. Revenue. Demand. Cost and average cost. And cost benefit.
You want us to do both or just the odd ones?
Every other one.
On which the application problems? There's an even revenue and an odd revenue, do the odd revenue. There's an even demand and an odd demand, do the odd demand. Find an odd problem that says that and you can do it. And you're good. And you guys know what every other odd means, right?
Yep.
Okay. All right. Go forth and conquer, chickens.